The agenda for this webinar will be scripting for hackers for day one, that's today, and it's about understanding the bash environment, introduction to variables, using the functions, creating scripts to automate tasks like scanning. So lots of things we are gonna do. So if you guys have a little bit knowledge in terms of Linux basics, and if you have Linux installed, so you can also parallelly perform the practical. I can give you tasks, and you can perform those tasks, and yes, that's how we learn, right? So let's start with our webinar, and the very first thing we're going to talk about the bash scripting, right? So when we are talking about the bash scripting, right, what is bash? Shell is a command line interface that allows users to interact with the operating system. So it acts as a bridge between the user and the kernel, right? It enables the users to execute commands, run the scripts, manage the system resources, right? So it performs command execution. So you can type commands that the shell executes, like you have ls commands, copy commands, multiple commands, right? You can write them in shell. Then it also performs script execution, right? So shell scripts, they can be written and executed, and they can automate the task and the processes that you want, right? Then it also does environment control. So what users can do, users can set and modify environment variables that affect the behavior of the shell and other programs, right? Then it does the file management also. So you can navigate to the file system, you can create directories, edit files, and manage permissions, right? So there are different types of shell that are there, right? Like one of them is bash. Bash stands for born again shell. Right. Now, when we are talking about born again shell, this is the most widely used shell in Linux distribution, and it has powerful scripting capabilities. And the older shells, like there were lots of shells, right? Uh, there was Bourne shell, there was Corn shell, there was C shell, right? All these shells were used in the starting of the Linux, right? So at that time, what happened? People, they were not able to access the older like history of what commands they have used, or autocomplete commands, or there was no GUI in that. So when born again shell came, this shell gave you lots of functionalities, like in born shell, the very first shell was born shell, right? So in born shell, you are not able to perform the arithmetic operations, right? Like addition, subtraction, those things were not, you were not able to perform, right? But here in born again shell, you can do that. You can check the history, you can go to the older commands which you have used, everything you can do, auto complete the commands, right? Auto complete the file names, many things you can do. And then now we are using z shell, right? So when we are talking about z shell, right, this is the latest one, right? It has color codings for different types of files. It has uh like like bash rc file, right, that you can modify. So it has been improved, right, from again born again shell, right? So that's a shell. Now bash is a command line interpreter also, right? So that command line interpreter, what it does, it's Unix shell, right? And it is used in Linux operating systems, and it was developed by Brian Fox, right? So what it does, it serves as a default login shell for most Linux distributions. And scripting with bash, it allows the task to be automated, it reduces the need for manual execution, and it enhances the efficiency. So with bash scripting, you can streamline your repetitive tasks or repetitive processes, which saves your time and efforts, right? And similar to traditional programming languages, bash supports the features like variables, conditional statements, loops, and it makes it a powerful tool for task automation, right? So that's your bash. Now, When we talk about bash scripting, for that you will need the basics of. So this is a Kali Linux, a distribution of Linux, right? And which is used for mostly used for the pen testing purposes. There is one more Parrot, right? So Parrot is also used, but the thing is that sometimes Parrot gives you errors, right? And compatibility issues with some of the tools, but that's also good, right? That's the thing that you can use. Now the thing is that when we are talking about this shell, so this is the place, the one which I have circled. This is the place which is your terminal, and this is the place where you will be writing the commands. I'm telling about those for those who are not aware about the basics of Linux and many things, right? Now, next thing is that when we are talking about Linux, so if you can see the prompt as a dollar, that means you are non-root user, right? You are a normal user. You don't have every single privilege in the system, and you don't have every single privilege to make changes in the system, right? Now, for becoming the root user, the very first thing that you write is sudo su. Yes. Now, when we are talking about sudo su, what does it stands for? What does it mean? Switch user, super user. Great. So when we talk about sudo su, it stands for super user do subs substitute user, right? That's what it stands for, and it will substitute the other user in place of this user, and that will be your root, right? So if I write sudo su press enter, it is asking for password. I entered the password, and you can see I am the root user now. So the prompt has been changed to hash, and here it is written root, right? That means I'm the root user. There is another way to find that out. If you are the root user or not, you can write who am I command, and it will give you that what username is yours and or what user you are, right? Then the second thing is that when we are talking about the Linux. So here it's written that in which directory you are in. My username is Kali, so that's why I'm in Kali user. If you install the Kali Linux operating system, like what we say, using like an image file, so at that time you can keep your name as you want, or even here also you can change the name, right? Now in this directory, like the very first slash which is written, right? This first forward slash which is written. What is that? What do we call it? This is the file system, right? Now in Windows, everyone has used Windows, right? So in Windows, you have that icon, this PC, right? In here in Linux, we have file system, right? Inside file system, everything is present, right? So you can see here is the icon of file system. If I click on that, so there are different directories: home directory, opt, proc, mount, media, boot, bin, for everything. So there are directories. Now you might have noticed that in Windows we call them folders, but in uh, Linux we call them directories. So will you call them folders? No. The thing is that directory means something which is in a manner or in a managed way, right? So if I'm talking about directories, like you might have seen telephone directories. So the telephone numbers back in the old days, like telephone numbers of every like let's say that's a police station. So police station is there, then ambulance, then there are phone numbers for let's say hospitals, and then lots of them, right? So everything was managed. The first few pages will be of hospital, then few pages will be for only police station, then few pages will be for ambulance, right? That's how it was managed. Same like that in Linux, everything is in a managed way. When you install any tool, its libraries will go to the lib folder, like its binaries will go to the bin folder, its service binaries will go into srv directory, right? So that's why it's managed, and that's why we call it directory. In Windows we have folders, we can put anything inside folders, right? It can be a file related to some other program, it can be an image, it can be a video, right? So things are not in a managed way, right? So that's why we call it directory. Now the inside file system, it shows that inside file system we have a home directory. Inside home directory we have the Kali directory, and that's where you are, right? Now the basic command that if I want to see the contents inside, I will write ls command. Yes. If I want to change the directory, I will just write cd. Cd stands for change directory, and let's say downloads, right? So I am inside the downloads directory. If I want to go out of the directory, one step back, so I will write cd space dot dot, right? What if I write cd space dot, single dot? Nothing will happen. So single dot in Linux means current working directory, and double dot in Linux means one directory back. Now, if you want to clear the whole screen, you can just write the command clear, right? Then we use the command ls. We have a format, like if I want the output in long format, so I will use the switch hyphen l, and it gives the output in long format. Now in this, if you will see, there are permissions written: read, write, read for a file with the name abc, right? If it is a directory, a d will be written in front of it, and then all the permissions of it. So that is ls space hyphen l. Now, if I write ls space hyphen a switch, if I use, so it will show you the hidden files and directories, right? Which were not shown in the output of ls or ls space hyphen l, right? So how you can spot that this is a hidden file or hidden directory? So you can just see this. If any file name or if any directory name is starting with a single dot, that's hidden. Now, the thing is that if you want to hide a file, you can just create a file and name it with the prefix dot, right? So if I want to create a hidden file, I will write abc nano dot, let's say apt, right? I'll write anything here, and you won't find apt here. But if I write ls space hyphen la, you will see that apt is here. So that means it's hidden now. Now, when we are working with Linux, we want to find out what is our shell. So I can write echo $0, and it will give you that what shell is there, right? Which shell we are using. Or you can also write echo dollar shell. This will give you the path of the whole shell, in which shell you are in, which shell you are using, right? That's the command to find out the shell. Now, the next thing is that we have variables, right? And when we are talking about variables, variables are used to store some data, right, in the script. So let's say, let's assume it as a container, right? It's a container where you can put anything. Let's say I want to store, uh, I want to put, let's say, wheat, right? Whatever you want. So let's say I want to store wheat. So I can store wheat in that container, right? Then I can remove that wheat and I can put rice in that container, right? Then I can remove the rice. I can put, let's say, maze in that, right? So it can be anything. So variable is a kind of container which is holding some value. Now it can be a number, a decimal number, or it can be a float, right? With decimals, right? Like 91.5, or it can be an like a string like ABC I want to store, right? It can be anything. It can be a character also. Let's say A I want to store, so A will be stored. So anything we can store inside variables, right? Variables are used to store the data so that we can use that data later in our script, right? Now the thing is that how to write a script. So I'm creating a directory with the name scripting, and here we'll be writing all the scripts. When you write a script, first thing, you are creating a file. I'm creating a file using Nano. Everyone knows Nano editor. So Nano is what? Nano is an editor, same like Notepad. You open files in Notepad, right? Same like that. Nano is a editor in Linux, and what it can do, let's say I'm writing script one, right? Dot sh. So extension will always be sh for bash scripts, right? So if I'm writing script one dot sh, what it will do, it will basically find the file with the name script one dot sh inside the directory scripting. If it is not able to find that file inside the directory scripting, right? So it will basically create that file, right? So that's Nano. So right now there is no file with the name nano. Sorry, script1.sh. So nano will do what? It will create a file with the name script1.sh and open it for editing. So if I press enter, this is the place where you can write anything you want. Yes, it will check for duplication also. That if there is a file with the same name, so if there is a file with the same name, it will open it for editing. It will not create a new one, right? Now the thing is that when you start your script, every script start with hash not slash bin slash bash. Every script in bash which you are writing. And this, it's called shebang, right? Mr. Shiva, Nano is basically not, you can say it is a kind of editor where you can edit the files, right? It will give you a GUI where you can write your commands or write your scripts or write your data, and it will save it in the format of text file or script file. It just depends that what extension you are giving, right? So that's Nano. Like you open in Notepad or Word, right? The documents, right? Same like that. Here we have is Nano in CLI. So this line is called shebang, and that's why this language is also called shebang lang, right? Well, what this shebang line is doing. So typically your bash interpreter, this is the interpreter which will be reading your code, and we are giving the path to the interpreter, right? There are two things, compiler and interpreter. So what is the difference between compiler and interpreter? Nano is not an IDE, Mr. Ayush. It's just an editor which edits the files, which opens the files, right? For editing. So IDE will be integrated development environment, right? Where you can develop, run, and test. Same thing. So that's a software. Nano is not a software, it's an editor. So there are two things, compiler and interpreter, and the biggest difference between compiler and interpreter is compiler is bit fast because compiler will check the whole code at once, right? And it will give you all the lines where the error is present, right? Interpreter will interpret the code line by line. So let's say there are 5 lines, right? And there is an error at line 3. So it will stop executing at line 3, give you an error that at line 3 there is an error. You will remove the error at line 3, again execute it, then it will say there is an error at line 4, right? Then you will again remove the error, you will execute it again, and then it will be executed, right? In compiler, it will directly give you that line 3 and line 4 have errors, right? So that's the difference between compiler and interpreter. So we are giving the path to the interpreter, that which interpreter to use when you are executing the code, right? That's why the shebang line is very important. So generally in many of the distributions, the path is same, like slash bin slash bash, right? And if you're writing the scripts in like other language, like you're using Perl or Ruby or Python, so you will give the path of Perl, Ruby, or Python. Like you will write user bin env and then Python 3, right? That's how you will give the path. Now, for writing the shebang line, there is a different way also, right? User bin env and bash. Now the thing is, this is more portable shebang line, and you may want to use this shebang line because it is more portable uh, as compared to the one which we wrote before, right? So some Linux distributions, what they do, they place the bash interpreter in different system locations, right? And this shebang line will attempt to find that location, but the other one will not try to find out the location. It will check on that location only. So this approach could be useful in pen test where you might not know the location of bash interpreter on the target machine, right? But for now, for simplicity, we are using slash bin slash bash because we know that in Kali Linux, that's the default path for the interpreter, right? That's the first line. Now, after that, when you are writing the script, let's say I want to print something, echo, what is your name, right? And then echo, my name is Ashish Jani, right? So what I'm doing, I'm just printing something, right? So for saving it, Control X, it says saved modify buffer, Y, and then enter, right? So this is script1.sh, right? Now for executing it, there are two ways. Either you can write bash space script1.sh, right? So it says it printed the same thing in front of me. What is your name? And my name is Ashish Dhani. But if you want to execute it in different way, so you have to give it executable permissions, chmod plus x and script1.sh. So by writing this, chmod stands for change moderations, right? So I have given the executable permission to script1.sh, and then I can write dot slash script1.sh, and it printed the same. This is the thing that we have written, right? But what if I want, uh, let's say I want the input from the user, that when the program executes, right? So it it should ask you a question that what is your name? The user gives the input as his name, and it says hello and the name of the user. So here I can see that there is a big need of something which can hold the name of the user or store the name of the user for a while, right? And that person is variable. Yes. Now, what variable does, variable will store. So how to take input from the user? So there is a command read, right? Read, and then the variable name, right? Whatever you want to name it. Let's say I want to name it A, right? So read A. So whatever input the user will give, that will be saved in variable A, right? Now, let's say I'm printing echo hello, and I want to paste the value whatever user has put. So user gave the input as his name and it got saved in A. So I have to call the value which is saved in A. And for calling the value, you use dollar symbol, right? So dollar and the variable, right? So whatever value is saved inside the variable will be saved here, will be printed here. So let's try it. What is your name? And you can see it got stuck, right? Now I have to give a name, right? So if I'm giving a name like, let's say Ayush, right? So it says, hello Ayush. Yes. So that's a variable, right? So every scripting language, it has variables, and variables are the names that we assign to memory locations that hold a value, and they act like placeholders or labels. So we can directly assign values to variables, or we can execute bash commands and store their output as variable values for to use for various purposes, right? So variables can include alphanumeric characters, as I told you. They cannot start with a number. They can contain an underscore. They cannot contain white space, right? So that's variable. Now, what I can do is I can unassign the variables also, right? Like I can write unset a, right? And then I can give a value a equals to Ashish, right? So now, what happened? If I execute the script, script1.sh, it is asking for name, right? And I'm giving the name Siva, right? And it will print hello Ashish. So what happened? In the variable A, the value Siva was saved, stored, right? And then it removed that and a new value Ashish is stored in A, right? And then it printed hello Ashish. Now the next thing is that we have the scope of the variables also, like global variables and local variables. So global variables are those, uh, we don't have to write echo Ashish. We are learning about variables, so that's why I'm putting the value inside A and then calling the value which is inside A. Now, as I said that there is a scope of variables also. So we have global variables and local variables. So global variables are those which are available to the entire program. But variables in a bash, can you can also scope them that they are accessible only from within a certain block of code, not outside that block of code. Those are local variables. So they are declared using the local keyword, right? So I'm creating a new file, variables dot sh. Now hash not slash bin slash bash, and then let's say I'm taking a variable. Uh, what do we name it? That's the hardest decision. So I have taken a variable publisher equals to infosec train, and that's a variable publisher, right? Then I'm taking print underscore name, and I'm creating a function of it. right? We'll discuss about the functions. And then local variable name, right? Then I have defined name equals to my name, right? And echo, call the name value and call the publisher also, right? And then close the bracket and print underscore name. I've just called the function, right? When you want to run a function, so you'll just call the function. Now control X, Y enter, chmod plus X variables.sh and dot slash variable.sh. So it's saying Ashish Dhyani by INFOSEC train, right? Now that is we have used it inside, we have used the local variable and global variable. So this is global variable, the publisher, right? So it can be used anywhere in the program, but this name variable, which is defined in the print name function, it can be used only inside this piece of code. Now if I write echo variable dollar name will not be printed because it is a local variable, right? Let's see. Here I have called the value of name. So there should be Ashish Dhyani printed, right? Control X, Y, enter, and dot slash variables dot sh. Variable will not be printed because it is local variable. So the name Ashish Dhyani was not printed. So that means it is a local variable. Now, next thing that we have is functions. We'll be using functions, but uh, let's discuss about some operations that we can do, right? Yes, sure, Kima. We can discuss about variables again. So variable is what? Variable is anything which can store some value for you, right? Now I've taken a variable publisher and I have written INFOSEC train in that. I've saved the value INFOSEC train. Then I created a function, and inside that function, I created a variable with the name, right? Now inside that variable, I saved a value Ashish Dhani, right? And then I called the value of name by and the value of publisher, right? And then I called the function. So when the function executed, it printed Ashish Dhani by INFOSEC train, right? Now that is only inside this scope, right? This is the scope of the variable between these curly brackets, right? Only these, right? If I'm using the variable name outside that piece of code, outside that block, this block, right? So that will not be printed. So it will only print variable and will not be printed because it is a local variable. It will not print the name, this value stored inside the name variable. So that's a local variable, right? So I have called the value of the publisher variable, control X, Y, enter, and dot slash variables dot sh. Variable will not be printed because it is a local variable, but it will print infosec train. That's the value saved inside publisher variable. So that's a global variable. That's why it's printing. Yeah, we can have many local variables inside that local loop. Okay, now we can do arithmetic operations also by writing a script. So let's say I want to do addition of two numbers. So in arithmetic.sh hash not slash bin slash bash, what I can do, I'm taking a variable whose value is 15 and second variable b, and I'm saving the value 16 inside it, right? Now I want to do the addition. How can we do the addition? I need a third variable c. C equals to dollar $a plus dollar $b and echo the sum of a and the value of b is c, right? Control X, Y, enter. Chmod plus x arithmetic.sh dot slash arithmetic.sh, and the sum of 15 and 16 is 15 plus 16. So it printed the thing as it is, right? It's not giving the value, it's printing it as it is. It's not performing the operation. So whenever you are doing these operations, you can use backticks expr for expression, and then it will work. Why it's not working? It's just calling the value and it's printing as it is, because inside C you have saved, you have not told it that you have to do the calculation. You have just told it call the value of A plus sign and then call the value of B. So that same thing will be printed. Now if I execute this, so it says the sum of 15 and 16 is 31. Now I have given it that you have to do this is an expression that you have to solve, right? You have to perform it. We have to tell the script that this is an expression or you need to perform the arithmetic operation. So by this we are telling that. So when you are writing the script, so the scripts that you have written, just check uh, your script. What I will do, I'll write echo, enter the first number and read A. Echo, enter the second number and read B. And the whole expression is same, right? So this time when user will enter, so it will be like this. Enter first number, second number, the sum of 12 and 12 is 24, right? Okay. Then one more thing is there, and those are called positional arguments. Anyone who knows what are positional arguments? So bash scripts, what they can do, they can take positional arguments, or you can call them parameters also, right? Which can be passed on the command line. So arguments, they are really useful. So when you want to develop a program that modifies its behavior based on the input which is passed to it or by another program or user, so then it can help you out, right? So arguments, they can also have change features of the script, right? So let's say you are a pen tester, so you have developed an exploit and send it to few colleagues, right? And each of whom will use it against a different IP address. So instead of writing a script and asking the user to modify it with their network information, you can write it to take an IP address argument and then act against this input to avoid having to modify the source code in each case, right? Now, when we are talking about the bash scripts, right? So bash script can access arguments passed to it on the command line by using variables like $1, $2, $3, and so on, right? Now the number represents the order in which the argument was entered, right? So what I will do, nano positional dot sh, right? Hash not slash pin slash bash, right? Now here, first thing, I'm taking a variable script underscore name equals to $0. It will print the name of the script which you are executing. Next thing, I'm writing, let's say echo. This is the first argument, $1, right? Then echo, this is the second argument and $2. Echo, this is the third argument and $3, right? And you can keep on going, right? Like this is the fourth argument, $4, right? And echo, the total number of arguments are dollar hash, right? Control X, Y, enter. Now, when you will execute this positional.sh, chmod plus x positional.sh dot slash positional.sh, with that you have to give the arguments, right? So let's say this script is about positional arguments. So when I execute this script, so it says this is the first argument, this, right? This is the second argument, script, right? This is the third argument, is. This is the fourth argument, about, and the total number of arguments is 6, right? So this is what is called argument, right? And one thing, if you notice that it has not printed that script name. So now this is the positional argument, and echo $0, or let's say echo dollar script underscore name. So you have executed dot slash positional dot sh, and these are all the arguments, right? How it can help you. So let's say you're writing a program to ping, right? And every user wants to ping a different IP address or different domain name. So you have written, I'm giving it ping underscore arguments dot sh hash not slash bin slash bash, right? Now you have taken a variable target equals to $1, right? Echo running the script $0, right? Echo pinging the target $target, and then ping command and $target. Control X, Y, enter, chmod plus X ping arguments.sh, and you have to give the IP address you want to ping. So let's say our domain name. So if I'm pinging google.com, so it says pinging google.com. So it started pinging the google.com, right? If I give any IP address 192.168.12.151, right? It started pinging that IP address also, right? So these are the places where you can use the positional arguments, and it will not, it won't basically, uh, you don't need to change the source code, right? So let's say there is an exploit. You wrote a code for the exploit. Right now, the exploit code will be running for different devices. Right now, if the exploit code is running for different devices, all those different devices will have different IP addresses. So instead of giving a specific IP address, you can use positional arguments so that when it will be executed on the system, so it will be executed dot slash exploit dot sh and then the IP address of the target system, right? So on that target system, it will be executing, right? So there you can use the positional arguments. Now we can create functions also. Now what are functions? Functions help us to reuse the blocks of code so we can avoid repeating them. They allows us to run multiple commands and other bash code simultaneously, right? So by simply entering the function's name, right? So you don't have to write the code again and again. If you want the same code, you can just write the name of the function, right? So for defining a new function, right, you can just write a name, okay, slash bin slash bash. You can write a name and put a parenthesis, right? Then start the curly braces and place the code you want, right? Let's say echo. We are learning advanced penetration testing, and close it, right? So this function is just printing something. Then if you want to call the value, just write the name of the function, say underscore name, control X, Y, enter. Now bash, and it says we are learning advanced penetration testing. That's how it printed, right? That's a function. That's where you use functions, right? When you want to use the same code multiple times, right? And that's how you create functions. Now we are gonna create scripts, right? So let me tell you some more things. What we have conditional statements as well, right? Conditional means if conditions, if and else conditions, right? And for that, what we need to know, there are comparison operators, right? So what are comparison operators? Equals to, right? Greater than, less than, not e not equals to, right? uh less less than, equals to or greater than equals to, right? So these are what? These are the comparison operators. So instead of this, you can also write hyphen EQ. That means equals to hyphen NE, not equals to hyphen GE, greater than equals to, right? Hyphen GT, greater than, hyphen LT, less than, hyphen LE, less than equals to, right? You can use them also, right? And then there are if conditions. So if condition means if the condition which you have provided it's correct, then your output will be printed, otherwise it won't, right? So if I write a code conditional.sh hash not slash bin slash bash, so I'm just writing a small code that echo enter the first number, echo enter the second number, right? And take the input, so read A and read B, right? Then you can start the if statement. If, and we have to be very uh, uh, like we have to be very careful while we are writing these statements, because in bash you only get errors because of the scripts or because of the indentation, right? So take care of indentation and spaces, right? If value of A equals to value of B, right? Then print A is equal to B, right? And then close the if statement. So for closing the if statement, you will use fi, right? Then if value of A is greater than, right? Or let's write hyphen GT, the value of B, then echo is greater than B and close the if statement. Then again, if A less than B, then echo is lesser than B, right? And close the if statement again, right? Control X, Y, enter, bash, enter the first number, enter the second number, A is lesser than B, right? Now the thing is that rather than writing these lots of statements, what I can do, I can write if A is equals to B, then print A is equal to B. If A is greater than B, so instead of if, I can use else if. Else if A is greater than B, then print A is greater than B, right? Else if A less than B, then print A is lesser than B, and then close the if statement. And even then, if you want some other statement to be added, you can use the else. Else echo these are not numbers, right? And we have closed the if statement, right? So instead of writing lots of if statement, we can use very less if statements, right? So control X, Y, enter, bash conditional.sh, A is greater than B, right? A is equal to B. So it says these are not numbers, right? Integer expression expected. So that's how you use conditional statements. Now, let's write a code, right? Now, in that code, what we'll do, I'll give you some time, right? In that time, what you have to do, you have to write a script. Now, in that script, what should be there? You have to check that the user who is executing the script, if that user is the root user of the system or not, right? You have to check that. So if else will be used there, right? And functions will be used there. So I'm naming my file check underscore root.sh hash not slash bin slash bash, and there I'll create a function check if root, right? And inside that function, I will write if EUID hyphen EQ 0. Then return 0, else return 1. Close the if condition, close the function. Then if check underscore if underscore root function, then echo user is root, else echo user is not root, and close the if condition, right? So basically in Linux, if your UID and GID is 0, then you are root user, otherwise you are not root user, right? Let's try to execute it. Bash. It shows user is not root. Now the last thing is that if I want to execute any command, right, in the output, so what happens, we have TTL values, right? Now what is TTL values? We have given the condition. That's how the if condition knows. So you have to give that if check if root is returning something, then to print the user is root. If it is not returning anything, that means the user is not root, right? So we have given a condition that when to return 0, when to return 1. So on the basis of that, it will be checking that if 1 is returned, user is not root, 0 is returned, user is root, right? So that's how it knows. Now, the thing is that when we ping any device or any operating system, right? So let's say I'm pinging my Kali Linux machine. So there is something which goes by the name TTL, right? TTL means time to live, right? And you can identify the operating system on the basis of TTL. So if your TTL value is 64, that means the target operating system is Linux, right? And if the TTL value is 128, that means your target operating system is Windows, right? So if I ping from here, ping 192.168.1.6, yeah, that's my Windows IP, right? So here you can see the TTL value is 128. So by default, the time to live value for Windows is 128, for Linux it's 64, for Mac OS it's 60, and for Cisco iOS it's 254, right? That's how TTL values are found, right? And from TTL value you can find out the operating system. So what I'm doing, I'm writing a script which will be finding out if the TTL value, like on the basis of the TTL value, it will find out the operating system of the target machine, right? So for that, I have to write a query that ping hyphen C1. I'm sending only one ping to, let's say, google.com, right? Now, out of this whole output, I just want the value of TTL. I want to extract the value of TTL, right? For that, what I will do, I will use the command grep, right? Grep hyphen o and grep what? TTL equals to the values can be between 0 to 9, the first number. The second number can also be between 0 to 9, right? And then third one can be there, cannot be there. That's why I've written asterisk, right? So it picked up exact TTL equals to 128. Right. After this, I also don't want this TTL. I just want 128. So then I will use the command cut. I will cut the output hyphen D for delimiter. Delimiter means the separator who is separating both of these, the equals to sign, right? So I will put equals to and then F2, right? So field number one is the word TTL and field number two is the number 128 and equals to is separating both of them. So if I press enter, so you can see that 128 is in front of me, right? That's how you modify the output, right? Now, if I want to write a script for that, so what I will do, nano ttl.sh and hash not slash bin slash bash. Now here first thing echo enter the domain or IP, right? Read IP. So I've taken a variable IP. Inside that, whatever user will enter, any domain name or IP, it will read it. Then I'm gonna take a variable. Give me a variable. Let's say I'm taking A, right? And I have pasted my ping command. And instead of this google.com, what I will write, I'll write $IP. So whatever IP will be there, it will be basically pinged, right? And then I will write the if condition. If value of a equals to 128, then print operating system is Windows, else if value of a equals to 64, then echo operating system is Linux or Linux. Else if value inside a is equals to 254, right? Then print operating system is Cisco iOS. Else echo you are hitting a firewall and close the if statement, right? Now control XY, enter bash ttl.sh, enter domain or IP. Let's say I'm putting the IP of 192.168.1.6, right? It says operating system is Windows. That's the IP of my Windows machine, right? If I again execute it, if I write 127.0.0.1, operating system is Linux, right? If you give any other domain, so companies, their like TTL values modified, so it won't give you anything like infosectrain.com, and it's not even able to ping because we have closed the ping. No one can ping the IP, right? Let's say google.com, right? So it says you are hitting a firewall, right? So that is how you write the code to find out operating system through TTL.